and we're going to tell you a little bit of a story of observability. So in this story, we've got 4 chapters. So we've got the first, which is the fairy tale of finding and fixing a problem. Then we're going to go on an epic debugging journey with our favorite man, Sid. The expert of DevOps, Victor, tells us about his grand Kubernetes expectations. And finally, we're going to teach you a little bit about the observability onion, as we like to call it. But first, our fairy tale of finding and fixing a problem. Once upon a time, there was an ogre called Shrek. And Shrek lived happily alone in his swamp. Life was good in the swamp. Everything worked as expected. There was peace and quiet. Shrek was happy, and nothing disturbed his equilibrium. Until one day that started like any other, Shrek heard a noise. What could that be, he thought to himself. He gets up from his dinner and finds there's someone in his bed. Okay, this is an easy enough problem to solve. He grabbed the intruder and swiftly kicked them out. But when he opened his front door, panic. There are more creatures everywhere, disrupting his peace. All the things he feared the most are happening. His once peaceful house was now overrun, and he didn't know why. He tried his usual I'm a scary ogre routine to no success. It had solved a lot of his problems before. Whatever happened, it was going to take some hard work to fix. To get his swamp back, he first needed to understand what was going on. After chatting with some of the fairy tale creatures, he finds out that Lord Farquaad is responsible for sending all those pesky creatures to his swamp. He'd found the root cause of his problem. Shrek just needed to talk to him and ask him to send the creatures somewhere else. An easy fix. Shrek and his friend embark on this epic journey to Lord Farquaad. Shrek understood his swamp well, but this journey took him to some brand new places. He spent a lot of time trying to understand and interpret exactly what he is looking at. And he also fought some completely pointless battles. Finally, he found Farquaad. He learned that the fix wasn't quite as simple as he'd hoped. To get Lord Farquaad's help, Shrek actually needed to rescue a princess from a tower. So once again, he journeyed through dangerous territories. Any step could have been fatal. He got distracted by a very dangerous-looking dragon that actually ended up not being a problem at all. He got burnt, he got hurt, but eventually he managed to find the princess. And on the long journey home, Shrek learned about her. He thought that maybe returning her to Farquaad wasn't the best solution to his problem. Maybe he should take the princess back to his swamp. They could get rid of the fairy tale creatures together. Or perhaps he could share his swamp with her and their new fairy tale friends. But unfortunately, Shrek overheard a conversation that sounded like it confirmed his original suspicions. With this new information, he returned to his original plan. After he returned the princess to Lord Farquaad, Shrek had realized he'd made a big mistake. His problems weren't actually solved. So once again, he had to fight. With the help of his new friends, Shrek re-rescued the princess, brought her back to his swamp, and they lived happily ever after. The end. So what's the moral of our story here? Okay, what's Shrek actually got to do with observability? Things are often good until they aren't. You may not actually be solving the problems you need to solve. And finally, knowing how to find and interpret the information is crucial to solving your problems. Just like debugging your K8s controllers. And hopefully we can pull this together a little bit more during our talk, and you can understand why Shrek is so important to observability. But first, I'm Kat Morris. I'm product manager at Syntasso. We build K8s, and I'm here with Derik.
Yes, I'm Derik. I'm a software engineer at Syntasso, building K8s. And we are here to talk about, title again, from panic to peace, making Kubernetes controllers observability success. Because in the end of the day, K8s is a controller. That's what we build, and we learn a lot through the journey.
So our second chapter, after our lovely fairy tale, is Sid's epic debugging journey. So I'd like you to turn your mind back to 2024, and in November, one of my greatest joys as a product manager is I get to spend a lot of time with our customers, not just hearing about their problems, but also the solutions they have to those problems too. And in November 24, I was invited to a community of practice event. And this community of practice was all about how this customer was using K8s, how they were implementing the functionality, and some things they'd learned about the product. And this is Sid. He was one of the main users at the time, and still is. He's one of our favorite guys, gives loads and loads of feedback, and has lots of strong opinions about how the product should work. And he was giving a demo. If you haven't found Sid yet, you should bump into him. He lives in Edinburgh. He's an amazing walker. He does like crazy walks. What's that, like 19.2 kilometers? Insane. So have a chat with Sid. He's a fun guy, but he was doing a demo of debugging. So in this debugging demo, it was how do I figure out something that's gone wrong in K8s and how do I fix it? So the demo of debugging. It started with creating a test promise. And for those of you who don't know K8s, you don't need to know it in detail, but a promise is just a CRD. So we created a test one which had something broken in it. All good. First thing you do, it's not try to show what happened with the promise, it's to show the 7 Kubernetes-related aliases that he had set up in his system. So these are long commands that it's hard to remember, so we've had to set up aliases to remind ourselves and make it easier to use Kubernetes. Not a great start for me as a product manager. It doesn't get much better, so Sid then applied the promise CR, which is really hard to see what's happening because you just get a CR applied. Not very informative. So we set up a watch on the controller logs. And if any of you know Kubernetes controller logs, it was something like this, which is super unhelpful in figuring out what's actually happened. So, okay, that's not the easiest thing to use. How about instead of the controller logs, I look at the pod logs. Fine, find the pod name, get the logs, have a look. They're pretty cool. However, the pod name changes, so you can't just look at the pod name. Fine, more work. We'll add a label to the container so that I can consistently get the container logs. Great. There's a label on there, can look it up every time. Fine. Next thing he wanted to show us was K8s events. So what's actually happening over time, what things are getting fired off. And this was when I realized we were missing some key capabilities in the product because Kubernetes logs are great, but like we have a whole product. We should be firing things that are more relevant to K8s. So put a pin in that one. We'll come back to it. We're only halfway through, folks. There's a whole other section of this. Number 7. Next, lists all the pods and checks all the errors, because it's not just one pod that gets fired, there are multiple. So each of those get their own labels and get their own view on the board. And we realized he's built a broken promise, so now he grabs for errors. And this is another watch on that command. So we have about 4 different windows open at this minute just to find one debugging scenario. And this is the bit that made me really sad, because he added a wait to the container to exec in to find the problem in a little bit more detail. So we're getting through a lot of information and having to do a lot of actions to fix a problem. And then he showcased our troubleshooting guide, which told you this exact thing, and this is how you should debug a problem. And at this point, I'm like, product manager, get better. You've done a terrible job. This is such a bad user experience. Because it took him 12 steps to finally fix and reapply this promise CR. And I thought, is this the experience we want for our customers? Is this really what we want to happen? Probably not. And it's showing that knowing how to find and interpret that information is crucial to solving a problem. So let's recap on Sid's pains there, because pains are always helpful to think about and how you solve your problems. Lots of long Kubernetes commands that are hard to remember. He had to alias them, not ideal. Non-predictable resource names means it's really hard to actually figure out what thing you want to look at. You've got to look in several places to find the root cause of your problems and actually get to the bottom of an issue. And once you have, that's still hard because there are a flood of repeated logs, which is classic for Kubernetes because of reconciliation loops and other stuff that Derik's going to talk about now and show how we fixed it. Because we need to improve it, so how can we?
All right, so let's just recap on the pain. The first pain is interacting with the platform, and it's how your user is actually going to get that information that they need. And what we thought about to solve this problem is giving our users different interfaces. So the first one is the one that we all know about, and the one that Sid was using, which is kubectl, which is the queen. It should always work. And this is like the standard way that users interact with your platform. And it has many ways, like with selectors and labels and gets and describes. All those commands should work. They should be able to get any information that they need. However, as you could see by the 7 aliases, sometimes it's hard, sometimes it's long. I bet many of you do a Control R and then try to find that particular command you run, or use Stern or some other to be able to figure it out. So what else can we do? We can build a CLI. A CLI is another terminal-based tool. We all love them. But it allows you to actually parse and grep and find the exact same piece of information that you want to display to your user with colors, with highlights, with anything that you need. I think there is some very successful CLIs out there like Tekton. For the ones of you that are familiar with Tekton, it's a pipeline tool. It's a tool to run workflows on top of Kubernetes. And instead of making you understand the entire data model, what they do is they provide you with a CLI that you can just say, Tekton run pipeline, and then it will actually go and create the necessary resources and pull the logs and show you that information there. The biggest problem with CLIs is that it's another thing to learn. Our users are, I'm not saying lazy, but they usually don't want to learn yet another thing to be able to interact with the platform. And furthermore, oftentimes they don't even have access to those things because they run in completely different environments and they cannot download and install it. So what else can you do? You can build a GUI. Yay, that's probably you, right? Like, we are all hardcore engineers. We all really like our terminals, our tmux, our neovims, and trust me, I'm with you. I don't actually want to build this thing. I don't like React. I don't like JavaScript. I'm like the person next to you. I'm allergic to it. However, there are some very good tools out there, like Headlamp, which is an open source tool, part of CNCF, that gives you a way to build interfaces on top of Kubernetes that don't suck that much. And that's kind of what we did. There's a lot of purple in this screenshot. That's our branding. But we built a tool on top of Headlamp that allows you to quickly get an at-glance view of what's going on in the world. And that's the thing that a GUI actually gives you, is that at-glance view. You can quickly go and see what's going wrong. So if you look at it, there's like something is red. You don't need to be a lot, like, very smart or understand a lot about K8s to see this is kind of where you need to look, right? And it also allows you to explore. The other thing that a GUI like this provides is links, is tabs, is things that you click and you can actually know where to go. You don't need to understand the data model to be able to explore what's going on in the system. So that's the first one. Interacting with the platform is hard. And we have the second thing, which is all logs are hard to understand. But why is that? Why is it hard to get logs right? So let's go through what happens when a user applies a promise. A bunch of Kubernetes resources, we don't need to care about them all, but when the user applies a promise, it triggers a promise controller. And let's assume there is a log line over there. How many times that same log line will be logged? Well, anytime that any of these resources change for what reason whatsoever, because all of those things will trigger reconciliation in the promise controller. So all of a sudden, when you have like a single log line, what does that mean? It means there will be loads of them, loads of the same log line. In fact, here's a exploration that we did with a customer, and I don't know if you can read it, but we managed to log almost 3,000 lines within a 2-minute window. And our customers actually raised an issue, and it was like, there's probably something wrong with my platform. I don't understand why it did spike. And it was just because we were logging it. So what can you do? Log less. Thank you. That's the end. No, just kidding. So let's take a look at the log lines again. Right, like this is a snippet of code that we have in K8s, and you can see in the arrows all of the log lines. And some of those log lines are useful, like I'm suspending job for the manual reconciliation. Some of them are maybe less useful, like checking status of delete pipeline. So who cares? Is the question that you should asking yourself. Is it operators? Is it the users? Is it developers or just you? And what are you using those logs for? Is it a heartbeat? Just to know, like, okay, my system is alive. Is it to debug an issue? That something is wrong, I need to understand what's going on. Or is it just like, I got here sort of log lines that you left when you were debugging and writing your code? The answer is yes. It's all of it, for all of them. So what can you actually do about it? You can implement log levels. Very basic, but it was surprising how much we had to work to come up with the idea of maybe we should have some log levels. So this is the same diagram that I had before, but in a whiteboard in our office. And then we came up with the very surprising industry standard log levels of error warning, info, debug, and trace. And each one of those things, each one of those levels are configured for the user, and it's meant for a different persona that is using your system. The second thing you can do to reduce your log lines is just reconcile less. So what if, instead of having, this is again a snippet of code of K8s. This is the work controller, which owns the work placement, as you can see over there. And what happens is every time that work placement changes, this controller will be reconciled. QBuilder, if you use QBuilder, it gives you a way to control when you're actually going to do the reconciliation. So we build throughout our controllers a bunch of predicates that say, okay, only trigger the reconciliation when this particular change, the status or this particular condition or this particular thing happens to my sub-resources. So that will dramatically reduce the number of times that the work controller will reconcile, which means less log lines. You can also add some structure. If you add structure to your logs, your users can hook into Elasticsearch or some other tools and get them sampled, and get them a little bit easier to queryable in a better way. So it's not only humans that are going to read your logs, but machines are also going to read them. And finally, it's Kubernetes. A bunch of things will go wrong, but not all errors are actually errors. So if you're trying to get something and you don't find, maybe try again in the next reconciliation. Do you need to log that line? Because that will be noise. There will be more things that are going to send your users, like Shrek, to the wrong direction, searching for fighting the wrong battles. So we applied all of those to our resources, and we were able to reduce the number of logs in a promise install by 67%. I actually did the maths, which is pretty good. There's still hundreds of log lines, it's still a work in progress. We're still trying to get it to just the absolute basics, but now the user can control and reduce it a little bit more. So that's chapter 2.
So chapter 3 is Victor's grand Kubernetes expectation. So we're going forward a bit in time now, over to January 2025. Our team has come back from holiday. We had a lovely Christmas. We've had our New Year's party. Everyone's feeling nice and merry and a little bit fat. And then one of our colleagues posts into one of our Slack channels. Drum roll, everybody. Nope.
I'm going to get there. There we go.
There we go. This video by Victor Farsik on the AI and DevOps toolkit. So if you've seen it, it's probably not new to you, but he does a lot of great videos on the CNCF ecosystem, DevOps tooling. He did one, and it came out on the 30th of December, so forgive us for not catching it immediately, which was about Crow. And Crow is a tool that provides abstractions on top of Kubernetes resources. Sounds quite a lot like what our product does, but on a bit of a smaller scale, a bit more Kubernetes focused than we are. And we watched this video, and his findings were the product is quite immature. It's actually hard to do a lot of stuff on it, and the logging isn't quite there. So as product manager, I was thinking, okay, he's got opinions on this, our product does something in this same wheelhouse. If he was part of our team, what would Victor Farsik do? But actually, I was more worried about him picking up our product and giving it a go and trying it out. So what would Victor Farsik expect of Kubernetes? And Chinyi, you're going to hate me. You're back on screen again. So I sent one of our top K8s engineers, and if you were here yesterday, you could have watched her talk. I was like, we've got this video by Victor Farsik. Could you watch it, give me a summary of what he says and what that would mean for us and what would we have to do differently? Because I want to make sure that if he does do a review or a video, I'm not going to get embarrassed if he does something, talks about our product. So why might we have been a little bit embarrassed here? So Derik told you a little bit about logs, but if we think about the user of our product, you've got a platform engineer, back to this diagram, they're going to apply a promise. Not crazy, but look at all of that stuff that's in the picture there. There's a lot of concepts that are more native to our product, more native to Kubernetes experts. You shouldn't need to understand these things to be able to successfully debug a problem. However, let's say the work placement goes down. Doesn't matter what it is. You've got all of these different levels to go through to try and find out where your problem is. How is that platform engineer, if we don't expect them to know what all of those things inside the platform cluster are, how are they going to figure out what went wrong? How are they going to fix it? Because things are good, it's fine applying a promise, it's fine interacting with your platform, it's good until they aren't. And when they aren't, first thing you're going to do is kubectl describe, and this is what we found, it's actually quite quiet. Like our product wasn't very noisy, it was quite hard to figure out what was going on. So how can a user find the broken component? And this is where we thought about the problem here. So a single apply may create many resources. This is really complicated. It can spin off a bunch of other different things, which means it's hard to go all the way back because you don't understand the relationship between them. It's not a simple system. Kubernetes isn't a simple system. So how can a user figure out what's going on when any of those intermediate resources could also fail? And then finally, how can that user debug and fix the issue when you've got all of these other problems and they don't understand the internals of your system? So Chinyi gave me a review, was very excited about the track of work. We don't know if this Vic guy, he still hasn't spoken about our product, but I won't be embarrassed if he does now. And Derik's going to show you why I'm proud now.
All right. So the pain that we had here, or the challenge that we're trying to determine is to fix is the data that the user needs to fix whatever is broken is hard to find. We didn't even know what exactly we needed to expose, though. So that's actually our first problem. What do we need to expose? So what we did was go back to the personas. So we have different people that use our software and different actors in the system. We have people writing the promise, we have people using the platform. So who is the data for? What is the data that we want to expose, and who is it for? So we considered those two things and came up with a few design principles. So from any resource to its sub-resources. So if something deep down, buried down 5 resources deep fails, we should be able to find a line that ties it back to the resource that the user is interacting. So when the user applies a promise, if the promise creates a job, the job creates a pod, the pod creates a work, the work creates a work placement, you should be able to find that thread from the promise, because that's what they are interacting with. It should be unsurprised for kubectl users. Yes, we have our interfaces, we have our CLIs, but users using the kubectl, they should be able to do gets and describes and still get the information that they need, get the events and the bits and bobs that they need in there. We should have a clear state indicators for all the K8s resources. So what we didn't have before, we had resources that have some status saying I'm ready, some status saying nothing, no status, or like status saying that they're available. So we should be able to see quickly for all the resources that we have, if it's ready, if it's healthy, if it's like something is broken with them. And to do that, we come up with some consistent status fields. So if the user knows what you expect, if they know that there will be a key called ready or available or healthy, it makes it easier for them, one less thing for them to learn about your system. And finally, whenever that state changes, we want it to be tracked through events. So in Kubernetes, you can emit events, and in those events, we're going to track all of the state changes. What does that mean in practice? Well, a bunch of stories. So happily, we delivered them all.
Yeah.
It's not that bad. We probably removed a few of them from the screenshot. But it was came out with like common labels. So the first thing we did was, well, if the user is using the kubectl, let's make sure that the resources have some common labels so you can track things across. So for example, a promise is the resource that the platform writer interacts with, platform engineer interacts with, and that creates a bunch of other resources. So if you add a label with the promise name to all of those sub-resources, it makes it a little bit easier for them to find who created that. Furthermore, Kubernetes uses CRDs. There is a CRD CR, and in there is a lot of things that you can do to make it easier for users to interact with your platform, like additional printer columns and validations. Additional printer columns is basically what allows you to extend what the user gets when they run kubectl get on the terminal. So this is an example of a change we made. So in the top we had the work placement. The work placement basically gets a work and puts you into destination, and that can succeed or fail. So before the changes we had age, which is the default thing that you get. And then we extended that to like, okay, let's add some information there that the user can quickly see where it is and if it's ready or not. So maybe none of you understand K8s that well, but you can understand what's going on the second screenshot, for sure. And to do that, we also need some status and conditions. So Kubernetes has a sub-resource called status, as most of you know, and there is an API convention doc that goes into a lot of details. This is that has 2,000 lines in about what you expect from your resource spec, what you expect in your resource status and conditions. So we went through that doc, we read through them all without any AI whatsoever. And we came up with some status and conditions for all of our resources. So this is a promise, so you can see this when you run describe, and you have things like work succeeded, it has reconciled successfully, the pipeline succeeded, and it's available. So now, at a quick glance, the user can see what and when was the last thing that happened. And as we talked about before, we also did some events. So whenever some of those conditions change, we emit an event. So the user can also do kubectl events or kubectl describe and see exactly when and how, what happened at that particular point in time and how many times it happened. They can also hook in their dashboards and monitoring system into those events and be notified when things change. And this actually saves us a lot of time. So I joke that the best thing we built in K8s was destination status. It saved us a lot of time. So destination is basically a pointing to a Git repo. And for that, you need a secret. And you'll be amazed by how many people cannot encode a secret in Kubernetes or have a new line because they forget the -n on the echo. So being able to quickly say, okay, get destinations and say, I cannot write to the state store was a life changer. All right.
So we've told you a lot there, and we're going to bring it all together with my favorite concept, which is the observability onion. And the observability onion kind of encapsulates this thought of you may not be solving the problems you actually need to solve because it's not just a single thing that you can look at. There are lots of layers, and this is why I told you about a story of Shrek in the beginning, because ogres are like onions, and observability is also like an onion. What do I mean? So, at the center, you've got the lowest level, the logs. They're going to be really helpful for people who understand the low-level concepts that you're doing, and you can configure stuff in it. Not always the most helpful, but you can build upon it into statuses. What's green? What's red? What's working? What do I need to fix? But to use a status, then you have to go into low-level detail and have a look at all of your different resources. So you build it up the next layer into events. How can I know at the point of time when something goes wrong? Can I get it fired at me so that I know when to look into the things, rather than having to continually check it? But metrics are like the next level up from that. So you've got the event telling you when things go wrong, but how do I know I've met my SLAs? How do I know my system has the uptime I expect? Well, you put all of those events together into your metrics to see how your platform is actually performing. And traces take that to the next level. So you've got your metrics of a long period of time, but what does this look like over the time period of a failure? What do the other services and systems look like? What are my series of events doing before a thing went wrong and after a thing went wrong, so I know what other impact that problem had? But these are all kind of low-level codey systems. You can take it up one more level into your interfaces. So we gave you lots of different interface options before. This is really good at basically sharing that information out. Do you, as an engineer, need a GUI? Maybe not. But your operations team might love one because they really care about those traces over time. And an observability GUI makes it much easier for you. Or your stakeholders are going to be super interested in the metrics of your platform. How does it perform? So getting that interface with all those lower levels can make it much easier for each of the people who are interested in your platform or interested in the observability of your platform be successful. So this is our summary slide. I have no time to go through all of the bullets, so please take a photo if you want, but we'll also be sharing the slides of all the things we've summarized today. And we did promise that we would have AI in here somewhere. Oh, no, wait, sorry. You can live happily ever after like Shrek. But we promised AI. We didn't actually talk about AI. We realized we completely ran out of time. So we did ask AI to come up with our observability onion for us, and it failed. So if you need better observability to actually make a better image next time, OpenAI, let me know. I've got a whole talk on it. So thank you very much for listening to us today. You can come visit us at our booth. I'm not sure we have time to question because we definitely overran. So come chat to us at the booth if you want to know anything. We'll be around all day. Thank you.